Hi, hello everyone. Good evening. Welcome to Unacademy ICSE and ISC YouTube channel. So this is Manisha, your class 9 chemistry educator. I have done my graduation as well as diploma and I am a gold medalist in both. I have 6 years of teaching experience. So today we are going to have our fifth lecture of atomic structure and chemical bonding. So I would like to tell you all about our official Telegram channel whose link is given in the description box. You can follow Unacademy Champions on Telegram channel so that you can receive all the important notifications related to your live classes, important offers ongoing on the Unacademy platform, also important notices about your upcoming final exams. Okay, so please tell me how many students are present in the class, who all are there in the class. Yes. Tell me in the chat section who is present in the class. Okay, so Vishal is present. Welcome Vishal. Good evening. Okay, also please do not forget to subscribe us on YouTube because we have a target to achieve, that is your 1000 subscribers. We want to complete it as soon as possible. Also please do not forget to hit on the bell icon so that you can receive the notification of the classes as soon the classes goes live. Okay. So in today's session, what we'll discuss? We are going to discuss your Niels Bohr's postulates and your discovery of neutrons. Okay. So these two important things we are going to discuss in today's class. So please, all of you, before starting the class, let me know if I am clearly visible and audible. Yes? Tell me fast. Am I visible and audible clearly? Okay. So, hello Avinash, welcome to the class. Namaste. Okay, good evening Avinash. So, how are you? Fine? Okay Avinash, tell me just if I am clearly visible and audible so that I can start the class as soon as I can. Yes? Good evening Varsha, very good evening. Welcome to the class. Okay. So everyone please tell me if I am clearly visible and audible. Should I start now? Okay, so let's have a quick recap of what we learned in the previous class. So previous class was all about your Rutherford's experiment and what were the postulates given by your Rutherford. So Rutherford model, in some books it will be given as your nuclear model, some books planetary model. Okay, thank you Varsha for confirming. So in nuclear atom, the protons and neutrons are there, which are responsible for your nearly all mass of the atom that is located in the nucleus, and your electrons are distributed around the nucleus and they occupy the most of the volume of atom. Now I compared the size of the nucleus with the size of the atom. That means the size of nucleus is very small as compared to the size of the atom. So I compared this with like that. If you take an atom to be a football stadium, your nucleus will be the size of marble kept in that stadium. So this is the model which was postulated by your Rutherford. Okay. Okay. Thank you Avinash. Thank you for confirming. So what were the features that I discussed with you in the last class? So if you have any doubt regarding any of the postulates or any of the findings or observations of Rutherford, based upon which he gave his model, the features of his model, whatever if you have any doubts, please let me know. Okay. So everything, these all are the main features of the model of Rutherford which he gave after observing the gold foil experiment. Whatever the observations he had from this experiment, he concluded them to define his new model, new atomic model, and thus we get so many features of the Rutherford atomic model, like atom contains nucleus in which your protons are there, that is a positively charged species which carries the entire mass of the atom. Electrons are distributed in the shells and all. So all these things we have already discussed. Okay Avinash, very good. So also we discussed the drawbacks of Rutherford model. So Rutherford model could not explain the structural stability of the atom. why the structure of atom was so stable, why we are able to see the matter and all, why atom is existing like this. These all things were not explained by Rutherford model, and hence his model was discarded. Then came your Bohr, Niels Bohr, with his model 1913. In 1913, he was the first to give the quantum mechanical model of the atom. Later, this model was given by your Erwin Schrödinger. Okay, so that's the model that we are using it today. Okay, so what were his postulates? He did not conduct any experiment. That's why whatever he gave about, whatever he told about his atomic model, that are considered to be the postulates and not the findings or observations. Okay, so what did he say? He told that electrons are revolving around the nucleus in the fixed orbit. Okay, that means every orbit will have fixed energy level. Those energy levels were termed as shells. Okay, or you can say orbits. Again, whenever any electron is revolving in its fixed orbit, it will never lose or gain any energy. And if any electron gains any energy or loses any energy, it cannot stay in the same orbit like it was staying earlier. So it has to either jump to the higher energy level or it can jump to the lower energy level depending upon the energy lost or gained by the electron. Okay. For simplicity, we have taken only 4 orbits, but there can be more than 4. Like in 7th period of periodic table, the elements which are there in the periodic table, they contain 7 orbits. Okay. So all these things we have discussed. Again, electron is like designated at K shell. So if it loses, let's say, if it does not lose any energy, and if it is there, it means earlier it was there in the K shell and it is not losing any energy, it is remaining in that shell only, then at such a state your electron will be termed as to be in ground state. Okay, termed at to be in ground state. And what is the excited state? Whenever your electron gains some energy or loses some energy. So basically whenever an electron gains energy, that will be termed as excited state because it is jumping to the higher level of your shell. Clear everyone? Okay, Avinash is telling yes, all clear, no doubt. Very good, Avinash. And the reason that your Niels Bohr gave for not falling of electron in the proton means nucleus and not collapsing of the atom, because the force of attraction that your protons possessed on electron is countered by the centrifugal force of moving electron, because any moving object will have centrifugal force, the force which tends to take the object away from the center. Okay, so that force will be equal to the force of attraction that is there from protons to neutrons, and hence the electrons will continue to revolve in their orbits and they will not fall inside the nucleus. So is it clear everyone? Yes, clear? No doubt is there in Niels Bohr's postulates for his atomic model. Is there any doubt? So Niels Bohr was the one who told us about this fixed energy levels, or you can say orbits, and named them as KLMNOP and so on. Okay. So no. Karan, hi. Hello Karan. What you are telling? No. See, these are the postulates of your Niels Bohr's atomic model that he gave in 1913, and thus he gave his nuclear model of atom. Okay, according to which inside atoms your electrons are revolving in fixed energy shells. Also, the centrifugal force due to the revolving of electron is responsible for not letting the electron fall inside the nucleus. Okay, Fazan is not in the class and rises from the west today, or what? Okay. Maybe he will come later, Avinash. He don't know about the schedule. Maybe that's why he has missed the class. Not missed the class yet. The class has just started, so he can come later in the class. Okay. Okay. So, any more doubts anyone is having in this Bohr's atomic model? Tell me fast. Any doubts in any of the postulates? The ground state, the excited state, everything is clear to everyone? Yes? Tell me fast. Karan, Avinash, Varsha, Vishal. Please everyone let me know if it is clear to you or not, because I want, okay ma'am, no ma'am, you cleared it already. Okay, thank you. Okay. Sure. Okay, so let's move further. Now we have to discuss the discovery of neutrons. So who discovered neutrons? Who discovered neutrons? Tell me fast. So neutrons were discovered by your James Chadwick. Okay, he was the one who discovered this neutron. And when did he do that? In 1932. Very good, Avinash. And he received Nobel Prize also for the discovery of neutron. Okay. So what did James Chadwick, okay, what did James Chadwick do in 1932? He took a thin sheet of beryllium, okay, he took a very thin sheet of beryllium, and what he did, he bombarded that beryllium sheet with the fast moving alpha particles, okay, very fast moving alpha particles, okay. Okay, so very fast moving alpha particles, what did he saw? He saw as a result that the certain neutral particles were also coming along with the protons. Okay, so neutral particles, neutrons were also coming along with the protons, and again these rays were made to fall on a paraffin wax. Okay, paraffin wax paper, which was consisting of so many hydrocarbons were there, and what it was observed, that along with protons, okay, protons were passing this paper and neutrons were also getting there, okay. So the detector was placed, okay, after the means where the rays was coming, this detector was placed. This was your protons detector, and it detected the proton, but it was seen that some uncharged rays were also there, okay. Which type of rays were there? Uncharged rays were also there, okay, uncharged rays were also coming out. So James Chadwick understood that along with protons inside the nucleus, there are some neutral species also which are not carrying any charges, but they have mass equivalent to protons, okay. They have equal mass to that of the proton, and thus he named this species as neutron. Clear everyone? Thus he named this species as neutron. Okay, so what did he saw? That these, why did he call these uncharged rays? Because he saw that these neutrons were not deflected by any electric or magnetic field. They were not deflected by any electric or magnetic field. Is it clear? Tell me fast. So you don't have to study this entire experiment in detail in class 9. You will be again studying this in detail in your class 11 in structure of atom. There you have to study this entire experiment thoroughly. Clear? Okay. So what did he took? He took beryllium, and what did he do? He bombarded it with alpha particles, light nuclei, that is your alpha particles. Or which were your alpha particles? He2 plus were your alpha particles, and he made to pass the rays that came out of beryllium through the paraffin wax, and it was seen that some charged rays were there, some uncharged rays were there. So charged rays were consisting of protons and uncharged rays were consisting of your neutrons, and thus he discovered your neutron. Okay, sure. So neutrons were not getting deflected by any electric or magnetic field. Now what is the mass of neutron? Just tell me everyone fast if you know. What is the mass of neutron? Tell me fast. So mass of neutron is 1.6 into 67 into 10 to the power minus 24 grams. It is just equal to your mass of proton. 1 AMU. Yes, you can say that. 1 atomic mass unit. Yes. Okay. So after this, all the 3 subatomic particles were discovered, and hence it was necessary to understand their arrangement inside the atom. Okay. So now let's study the modern structure of atom. Then we will study the Bohr-Bury electronic configuration of an atom. then valency, then isotopes, isobars, isoelectronic species, and then your chemical bonding. Okay. So I hope it is clear to everyone. This beryllium experiment is clear to everyone. Yes. So Avinash is telling clear. Karan, Vishal, and Varsha, please tell me if it is clear to you or not. Yes? Okay. So before we proceed to our next topic, that is modern structure of atom, I would like to tell you all about this Unacademy Plus subscription. So if you really wish to take the subscription, the time is just now, because Unacademy has started an offer from 25th to 27th of January. That if you take the subscription for 1 year, you will get 26 month subscription just for free. Okay, 6 month subscription you will get for free, and see, you can have a lot of benefits from the subscription. Okay. Ma'am, was Chadwick trying to find the reason why atomic weight was more than expected? Yes, Avinash. He was trying to find the reason. Yes, that we will do. That is the reason that why Chadwick means did this experiment, because see, that time it was known that atom was containing your electrons and protons. Okay. So for example, if we want to take out the atomic mass of, let's say, helium. Okay, atomic mass of helium. So atomic mass of helium was supposed to be 2 AMU, because it was containing 2 protons. Okay, but what it was seen that its mass was approximately 4 AMU. Okay, or you can take the example of other atoms also. So it was therefore misproposed, or you can say it was thought, that inside the nucleus of an atom there also exists another subatomic particle which has equal mass to that of the proton. Okay, so, and that particle should possess any charge or something like that, or it should be equal to the mass of proton. But when Chadwick did this experiment, he found that the species was having the mass equal to that of the proton, but it was not containing any charge, and in this way your neutrons were discovered. Okay, so yes, you are correct, Avinash, that Chadwick was trying to find the reason that why the atomic mass of expected atomic mass and calculated atomic mass was not getting equal. Okay, so this led to the discovery of your neutrons by this beryllium bombarding experiment. Clear? Is it clear, Avinash? Okay. Okay, so I was telling all about about the subscription offer that is ongoing on the platform. So see, we have many batches starting on the platform just for your exam preparations. Okay, so you can join this Mavericks batch, because this is the ongoing batch in English. Okay, again, your India's top educators are teaching in this class. Again, if you take 9th class subscription, you will get 10, 11 and 12 subscription just for free. Okay, that is again an amazing thing. Your same thing is there in the Hindi language also. Udan batch has started from 17th of January, and again from 1st of February we have new batches starting for your final exams preparations. We have a subscription starting from 3 months to 48 months, so you can take it accordingly. But do not forget to use my code Manisha Live, which will give you 10% discount. Okay, also this offer was already there, that if you take the subscription before 31st of January, so if you take the subscription for 12 months, you will get additional 3 months. But again, there is a new offer, that if you Republic Day special offer, which is there, means if you take the subscription for 1 year and above, you will get extra 6 month subscription just for free. Okay, so please do not miss this opportunity. 6 months free subscription just in the price of 1 year. It is commendable. And also do not forget to use my code Manisha Live, which will give you 10% discount. Okay. Okay, Avinash. Yes, tomorrow is 26th of January, and that is a Republic Day. So yes, patriotism is there. I don't know why I'm feeling patriotism more than enough. Okay, because you are having holiday tomorrow. That's why maybe. But you won't be having holiday in the class. We will have class tomorrow. Plus classes will be there. 5:15 p.m. we will have our plus class tomorrow. Sorry, not plus class, special classes. Okay. So do not forget to join this class 5:15 p.m. Okay? We will have our special class. Okay, so we are having special classes on Unacademy app which you can join, and there are so many features of Unacademy special classes, like you can have real-time interaction with me, you can chat with me, you can use emojis, you can participate in the live quiz, poll leaderboards are there, you can ask questions using the question tab. Okay. Ma'am, I don't know why I'm feeling bad. Okay, maybe we have a holiday tomorrow and I could go out in the morning to play cricket with my team. Okay, Avinash, it's good that you will go to play cricket, but do not forget to join the class at 5:15 p.m. tomorrow, okay? So how can you watch my special classes? You install this Unacademy Learner app, click on Get Started, enter your phone number, and after that you will receive an OTP. You will sign up using your email ID. After that you need to choose your goal, select your class and the language, and click on notify me for whichever class you want to attend live. So as soon as the class will go live, you will receive the notification. But do not forget to use the code, that is Manisha Live, to unlock all the free special classes. Okay. So now let's start with our class. Okay, so modern structure of atom. How can I miss your class, ma'am? This is like sun rising from the north. Thank you so much, Avinash. Thank you so much. Okay, thank you so much for being such a sweet student to me. Thank you so much. Now let's study about the modern structure of atom. Okay, modern structure of atom we are going to start now. What is this modern structure of atom? So according to the modern structure of atom, your atom is consisting of two parts. Okay, your first part is nucleus. Your atom is divided into nucleus, and so much of empty space is there. Okay, so much of empty space is there in which there are imaginary paths called orbits. Okay, so you can call that empty space as extra nuclear region. Okay, this is your extra nuclear region which is there inside the atom. Okay, so this is the two parts where your atom is divided. Now what is this nucleus? What is this nucleus? So everyone, whoever is watching the class live, please note down the terms that I am giving here, or you can note it down in your copy. Also you can take the screenshot as you wish, because if once I remove these things, I will not be able to bring it back. Okay. Okay. Now nucleus is there, that is present at the center of the atom. Yes. So nucleus is present at the center of the atom. All the protons and neutrons are remaining inside the nucleus, and entire mass of the atom, okay, entire mass of the atom is concentrated in the nucleus itself. So entire mass of the atom is concentrated in the nucleus itself. Okay, so and overall charge, if you talk about the overall charge of nucleus, all of you please tell me what will be the overall charge of nucleus. What is the overall charge of nucleus? Everyone, are you able to see the screen? Are you able to see the things that are written on the screen? Please let me know so that I can use a different ink for writing. Overall charge on nucleus, Avinash. Overall charge on nucleus is 0. How it can be? Overall charge on nucleus is how much? Tell me fast. So overall charge on nucleus is positive due to the presence of the protons inside the nucleus. Okay. So overall charge is how much? Zero, not 0. Sorry, I've written 0 only and telling positive. It should be positive. Okay. So I saw the answer of Avinash and I wrote 0. But the overall charge on nucleus is positive due to the presence of positively charged protons, because neutrons have no charge. So that's why your charge of protons will be the overall charge of nucleus, and that is fine. That is your positive charge. Clear? So sorry, I told about atom. Okay, Avinash, no worries. Clear, everyone? This thing is clear? Yes. And neutrons and protons are collectively called as nucleons. Okay. So neutrons and protons are collectively known as nucleons because they reside inside the nucleus. Clear, everyone? Okay, very good. Now let's talk about the extra nuclear region. Okay. So as we have talked about nucleus, let's talk about the extra nuclear region. Okay, I should remove all these things. Okay. So this we have already talked about. Now let's talk about your extra nuclear region. So what is there in extra nuclear region? Your imaginary paths called orbits. Okay. So students, please give me a moment. Somebody is at the door. Let me just go and check. I will be back in just a moment. Okay. Be there in the class. Okay. Don't go anywhere. I will be back. Okay, everyone. Very sorry. I'm back. Okay. Okay, so extra nuclear region. What is this extra nuclear region? So extra nuclear region is in the region that is outside the nucleus. So this region is outside the nucleus, okay, in which your electrons are present. In which electrons are present, okay, and which are revolving, okay, revolving around the nucleus in their fixed path or imaginary path, you can say. Those are known as orbits. So in orbits, okay, they are revolving around the nucleus in orbits, and these orbits are called as energy levels, and they are designated as K, L, M, N, and so on. Okay. Now tell me the maximum number of electrons. Maximum number of electrons that can be accommodated in one energy level is given by which formula? Maximum number of electrons that can be accommodated in one energy level. Tell me, everyone, what is the formula? Yes, Avinash. Okay, very good. 2n square. This is the formula of maximum number of electrons that can be accommodated in one energy level, where n is the number of orbits. Okay, n is the number of orbits. So clear, everyone? Yes. Now let's talk about your atomic number, after that atomic mass, and after that we will talk about the Bohr-Bury scheme of electronic configuration. Clear? So let's erase it all and let's start now. Okay. So atomic number is what? Atomic number is written by the symbol or represented by the symbol Z. So atomic number is nothing but the number of protons found inside the nucleus. This is the number of protons in any atom is your atomic number. Why we are not calling it number of electrons? See, general conception, when your atom is electrically neutral, in that case your number of protons is equals to number of electrons, and we took atomic number to be the number of electrons. But in case if your atom is participating in any reaction and acquiring any charge, so what will happen? The number of electrons will change. So that means that your atomic number will also change? No, atomic number never changes. That's why your atomic number is taken to be the number of protons and not the number of electrons. Clear? Yes, very good, Avinash. Number of total protons present in the nucleus. Very good. Now, this is the feature which is used to distinguish. You can use to distinguish, okay, distinguish the atoms of different elements. So if you want to distinguish the atom of different elements, the first and foremost thing is their atomic number. Okay, because atomic number, or you can say valence shell electron, are responsible for the chemical properties of every atom. Okay, clear everyone? Is it clear? Okay. So this is all about your atomic number. Let's talk about your atomic mass. So atomic mass is nothing but the number of protons plus neutrons. It is not number of protons plus electrons, but number of protons plus neutrons. I hope it is clear to everyone. Yes? Is it clear? Tell me fast. That means if you add number of neutrons to atomic number, it will come out to be your atomic mass. Clear? Is it clear? Just tell me fast. After that, I will start your distribution of electrons in the orbits according to Bohr-Bury scheme. Clear? Okay, Avinash, very good. So let me remove all these things. Okay. Now, Bohr-Bury scheme in electronic distribution in the orbits. Okay. So what were the schemes followed? Okay. Now first was that Bohr and Bury tried to analyze how these electrons are distributed in different shells, because that 2n square was the formula given for the arrangement of electrons in different orbits. But inside the orbits, there were certain suborbits known as subshells, or you can say inside that we also have orbitals in which your electrons were present. Okay. So Bohr and Bury decided to give a scheme which will decide the electronic distribution in the orbits. Okay. So they suggested that the electrons in an atom are distributed in different orbits or shells present inside the atom. Of course, that is there. So every electron will be divided accordingly. So the following rules were there. So following rules were devised by, are followed for writing the electronic distribution. See, Avinash, Bury was a scientist who was helping, okay, who was helping your Neil Bohr to decide this scheme for electronic configuration. Okay. So basically, he is known for this electronic configuration only, and his full name was like J.B. Bury. Okay. Understood? Yes, Avinash, clear? Okay. Okay. So, okay. So I suppose Avinash, it is clear who is Bury. So your Charles C.R. Bury, okay, he was the one who proposed this model for this atom with the arrangement of electrons, means how these electrons were arranged inside the atoms. Also, he was the one who explained the chemical properties, means how it was depending, means how these depending upon the valence electrons. Also, Neil Bohr, when he gave his atomic model, his was the dominant atomic model, because no, means his model gave the accurate reasons for whatever was happening inside that. So along with your Neil Bohr, he decided to provide a scheme to know how these electrons were distributed inside the shells, orbits or subshells, you can say. Is it clear, Avinash? And that's why the model was known as Bohr-Bury electronic configuration, or you can say Bohr-Bury atomic model. Yes? And Bohr-Bury was only the one who gave this octet rule. Yes. And Bohr-Bury principle is only known as octet rule, according to which the valence shell or outermost shell of every atom should have 8 electrons. Okay. So Bohr-Bury was the one who gave this octet rule, or you can say this principle was named as octet rule. Clear? Should I proceed now, Avinash? Is there any more doubts? Okay. So we will talk about the Bohr-Bury scheme and what rules were followed. So electrons were arranged according to their potential energy in different energy shells or levels. Okay. Now the maximum number of electrons that can be accommodated in a particular shell is given by the formula 2n square. Okay. So for first shell, so for example, for first shell, that is your K shell, the number of electrons that can be accommodated were 2 electrons. Okay, because it has only one subshell. Yes, one subshell means one orbital. That means it can accommodate maximum 2 electrons. Now let's talk about your second shell. So second shell was your K shell, which can accommodate 8 electrons. Okay. Now 8 electrons, why? Because L shell has 2 subshell. That means it has 4 orbitals, which can again accommodate 8 electrons because 2 electrons each orbital. And see, like this the means process will go on. Like third shell will accommodate 18 electrons because that have 3 subshells and 5, 3, 8, 9 orbitals. Okay. F subshell means if we talk about the fourth shell, that is your N shell, that can accommodate your 32 electrons because there were 16 orbitals and 4 subshells. Okay. So like this the means arrangement was given by this Bohr-Bury, that is the maximum number of electrons that can be accommodated in a particular shell was given by the formula 2n square. Clear? Yes. After that, electrons cannot be accommodated in any shell unless your inner shells are filled. Okay. So first your inner shells have to be filled. After that your higher energy levels can be filled. Third rule was that outermost electron can have maximum of 8 electrons. Okay. So second rule was what? First rule, though, you understand that maximum number of electrons that can be accommodated per shell was 2n square. Second was that first inner energy levels have to be filled. First inner energy levels will be filled. After that higher energy levels. Okay. So this was like your increasing order of arrangement. Okay. And what was the third rule? I am writing the third rule over here. So I don't have any more space. That's why I am writing the third rule over here. So third rule was that outermost shell. Okay. Outermost shell can accommodate maximum 8 electrons. Okay. Even if it has the capacity to accommodate more electrons, it will always accommodate maximum of 8 electrons. So, for example, if you want to see the electronic configuration of calcium, what is its electronic configuration? 2882. For potassium, it is 2881. It is not like that. Your third shell cannot accommodate 10 electrons, or this cannot accommodate your 9 electrons. Okay. But the thing is that according to the octet rule, maximum number of electrons that can be accommodated in the outermost shell is your always 8 electrons. Thus, your octet rule was given by your Bohr and Bury. Clear? So, your octet rule was given by Bohr and Bury. Is it clear, everyone? So, the stability of the atom based on octet rule was explained by your Bohr-Bury electronic distribution scheme only. Okay? And the outermost shell of a chemically stable atom. Okay? If a atom is chemically stable means the atom which is participating in the reaction. If it is stable, that means it has attained the maximum number of electrons that it can accommodate in the outermost shell, that is 8 electrons. So chemically stable means the atom which is stable in the chemical reaction after participating in the chemical reaction. So Bohr Bury were together known for giving this octet rule, again for providing a definite electronic distribution scheme, and Bury was the one who along with Niels Bohr gave this atomic model, or you can say improved this atomic model. Okay, and thus we got this octet rule, this electronic distribution, this 2n square formula from this model only. Okay, so this was all about your Bohr Bury electronic configuration scheme, and using this electronic configuration we can write the electronic distribution. See, in the electronic configuration is different thing, electronic distribution is different thing. Okay, do not mix these two things, because electronic distribution is showing how many electrons are present in each shell. Okay, in each orbit how many electrons are present. Electronic configuration will show how many electrons are present in each subshell inside the orbit. Okay, in each subshell inside the orbit having orbitals. So that is your electronic configuration, and that was given by your Bohr principle, Pauli exclusion principle, and Hund's rule of maximum multiplicity. So these three rules were used to define the electronic configuration. That is different, that was given in Erwin Schrödinger model, that is quantum mechanical model that we are using today. This was your electronic distribution scheme, means just to tell you the number of electrons that were present in each orbit, or you can say shell. Yes, clear? Hello Dominators, welcome to the class. No, Dominator, we don't have Menti today. We don't have Menti now. Okay, we can have it in future, but right now we don't have any Menti. Okay, it is in no Avinash. On Unacademy also Menti quizzes are there. Okay, but we have not conducted yet any Menti quizzes. Okay, for other courses like CBSE and all batches, there are Menti quizzes. It is not like Vedanta is having. Unacademy is also having Menti quizzes. Okay, so we will soon have Menti quizzes. Don't worry. Okay, clear? Is it clear, everyone? This thing is clear. Just let me know. Yes? Okay. Yes. Okay, Dominator, you know this. Okay, we will have Menti quiz soon. Okay, so that you can revise, you can participate in the polls and can revise well for your upcoming final exams. Okay. So should I proceed further now? Is this electron distribution clear to everyone? So who was this Bury? His full name was Charles Ruggles Bury, or C.R. Bury you can say, and he was the one who produced an atomic model along with Niels Bohr known as Bohr-Bury atom. Also he was the one who joined with Niels Bohr to provide a scheme for electronic distribution in the orbit. Okay, so there were 4 rules. First rule was that maximum number of electrons can be accommodated by the formula 2n square. Second rule was that first your inner energy levels will fill, after that your higher energy levels will be filled by electrons. Third rule was that octet rule, which was according to that outermost shell of any electron can have maximum of 8 electrons, that is the octet rule, to become stable. And fourth was if an atom is chemically stable, that means if an atom is stable in any reaction, that means it has already attained this octet rule. Clear? Ma'am, then I would like to have it. Ma'am, I like competition. Okay, Avinash, will surely have it. We will have it soon. Okay, I will have to organize this Menti quiz. I will take it as soon as possible. Okay, clear? Is Bohr-Bury electron distribution scheme is clear to everyone? Please let me know. Okay. Okay, very good. And based upon this octet rule only, your elements or atoms take part in the reaction just to stabilize themselves, just to have a stable electronic configuration. Okay. So understood what is the difference between configuration, electronic configuration and electron distribution? Is it understood or should I explain you this with an example? Okay? Okay. Please take a screenshot. Okay. So one more thing, do you know that you have to study Lewis octet rule also when you will go to standard 11? Okay. So this octet rule was given by this Bohr and Bury, but actually the idea of this that any atom having 8 electrons in the valence shell will be chemically inactive as inert gas was given by your Lewis. Okay, so that was your known as Lewis octet rule. Clear? So is this clear everyone? So you are going to study this Lewis octet theory when you go to standard 11, which tells that it is a tendency of any atom to have 8 electrons in the valence shell, and based upon this theory only Bohr-Bury included this in their Bohr-Bury electronic configuration scheme. Okay? Okay. So Lewis octet theory is also there. Okay. Now let's try to understand the how to write the electron means configuration, or you can say electron distribution. So let's suppose we have to write the electron distribution of not calcium. Let me give you something tough. Okay, okay. So let's try to write the electronic configuration of phosphorus. All of you please tell me what will be the electron distribution or electronic distribution of phosphorus. Tell me fast. Tell me fast everyone. Do you know the electron means atomic number of phosphorus? Then only you will be able to give its electron distribution. Okay. Very good. It is 285. Very good. So now let's talk about the valence electrons. Okay. So we will talk about now valence electrons. Okay, so valence electrons are what? Number of electrons that are present in the outermost shell are known as your valence electron. So electrons present in the outermost shell are termed as your valence electrons. And chemical properties of every atom is decided by these valence electrons only. Okay, so chemical properties are you can say depend upon valence electrons. Okay, clear everyone? So any atom having 1, 2 or 3 electrons in their outermost shell as valence electrons will be termed as metal. Okay, and any atom having 4, 5, 6 or 7 electrons will be termed as non-metal. But basically those who have 4 electrons in their outermost shell, they show some properties of metals, some properties of non-metals. So they are like your metalloids. Okay. Now all of this clear? Everything is clear to everyone? This valence and all. Calculation of valency, you know, everyone knows this calculation of valency. Tell me fast. Do you know how to calculate the valencies? Then I will proceed to your isotopes, isobars and isoelectronic species. Okay, very good. So now let's talk about the isotopes. So all of you know this. What are these isotopes? Isotopes are those form of element, okay, different forms of the same element, different forms of the, yes, Avinash, then tell me what are isotopes. I'm waiting for your answer. What are isotopes? Okay, one more thing that I want to tell you, that the term isotope was given by Margaret Todd. Okay, this term was introduced by Margaret Todd. Okay, isotopes. Now tell me what is this isotope? Fast everyone. Same atomic number, different atomic mass. Very good, Avinash. Yes, so different forms of the same atom having same atomic number but different atomic masses. Yes, but different atomic masses. Clear? So, atoms of the same element, or you can say different forms of the same element. Okay? So, different atoms of the same element, not different forms I should write. I should write different atoms of the same element. So, different atoms of the same element having same atomic number but different atomic masses. Like hydrogen has 3 isotopes, protium, deuterium and tritium. Yes, protium, deuterium and tritium, where you can see atomic number is same but atomic mass is changing because isotopes have different numbers of neutrons. They have different number of neutrons and same number of protons and electrons. Yes, it is clear. So isotopes will have different number of neutrons but same number of electrons and protons. Okay. Similarly, your chlorine has 2 isotopes. Okay. Yes, clear. So everyone, please tell me. Is it clear? Because this is very easy. Okay. So isotopes, chemical properties are same. Isotopes have same chemical properties. Okay, chemical properties same, but physical property is different. Why physical property is different and why chemical property is same? Can anyone tell me? Why isotopes have same physical properties but different chemical properties? Tell me fast. Sorry, I told just reverse. Isotopes have same chemical properties and different physical properties. Why this is so? Okay, different physical properties means such as your boiling point will be different, density will be different, okay, melting point will be different. So why these isotopes have different physical properties and similar chemical properties? Can anyone tell me? Yes, Avinash, can you tell me? Very good, very good. So isotopes have different number of neutrons, that means different atomic masses. That's why their physical properties are different. So as masses increase, the boiling point, density and all of these increases. Okay. So different atomic masses due to. And chemical properties same because of same atomic number. So clear everyone? I hope it is clear. So we have so many applications of isotopes. So I am removing this. Avinash, do you want to take a screenshot of this thing? Or should I remove it? Okay, so I am just removing it. Now let's talk about the application of isotopes. Okay, very good. Application of isotope means like uranium is used as a fuel in nuclear reactor. Your uranium is used as a fuel. Okay, which uranium? 238U92. This isotope of uranium is used as a fuel in nuclear reactors. Okay, now cobalt 60. This is used in the treatment of cancer for radiation therapy. Okay, iodine is used in the treatment of goiter. That is your I-2853, I-12853. This isotope of iodine is used in the treatment of goiter. So there are many different uses of isotopes. Clear? Is it clear? Okay, so these are your isotopes application. I hope it is clear to everyone. Yes, some elements have their radioactive isotopes also, like uranium is there, it is having a radioactive isotopes. Okay, okay, very good. So these are all your isotopes example. Okay, I hope it is clear to everyone. In some books it is given as 128, in some books it is given as 131. Please do not get confused. Okay. Okay, now let's talk about your isobars. Okay, we will talk about now isobars. What are isobars? So isobars are different atoms. Okay, different atoms of different elements. In isotopes, it was the different atoms of the same element, but here the different atoms of the different elements. So elements will also be different, having same mass number. Okay, here the atomic mass will be same and atomic number is different. Okay, so in isotopes, the isotopes were belonging to the same element. They were different forms of atoms of the same element. Like hydrogen's isotopes were protium, deuterium and tritium. But isobars are basically your different atoms of different elements. Okay, they have same atomic mass and different atomic number. Okay, they have different atomic number. Clear everyone? So can you give me an example of isobars? Can anyone give me an example of isobars? Tell me first. Yes? So isobars example can be like argon and potassium. Okay, very good. Yes, argon and calcium, argon and potassium are also there. Okay. In some books you will find the argon and potassium also. And argon and calcium are also there, having different atomic number but same atomic masses. Again more carbon and nitrogen. These are also isobars, no? Carbon and nitrogen. Carbon has atomic number 6, nitrogen 7, but both have atomic number 14. This is your C14 isotope of carbon. C14 isotope of carbon. Carbon has 3 isotopes, C12, C13, C14. So C14 isotope of carbon is an isobar with nitrogen. Clear everyone? Is it clear? Tell me first. So isotopes are those means atoms having same number of protons, or you can say same number of electrons too. Isobars have same number of neutrons. Okay, what they have? They have same number, or you can say atomic mass is same. Okay, clear everyone? Okay, thanks ma'am, you spent your power. Okay, clear everyone? Is it clear? Just tell me once if it is clear. Okay, okay. Now, thanks ma'am, you spent your precious time for teaching us. Thank you Avinash, because of you students only I get this energy to teach you all, so that I can bring the best of me and I can teach everything that I know, that I have studied yet and I have in my mind. Okay, so thank you everyone. So I hope it is clear to everyone. Isobars, that is they have different atomic number but same atomic mass. Clear everyone? Is it clear? Should we proceed to isotones now? Yes, I want to tell you about isotones also. Okay, so let's talk about isotones. Now, what are these isotones? Because in your book, we have been given only about isobars and isotopes. What is this isotones? Okay, so they are the atoms of different elements having same number of neutrons. Okay, so they are the atoms of different elements having same number of neutrons. So neutrons are same in isotones. Okay, let's take an example over here. That isobars, okay, isobars were there, C14 and your nitrogen were your isobars. You can see in both the cases number of neutrons is equal. That is how much? That is coming out to be your, sorry, very sorry. Okay, so both contain your 7 neutrons. Clear? Is it clear, everyone? Please tell me. They are the isotone species. That means the number of neutrons will be same. Clear? Can you give me more examples? Okay, very good. So, can you give me more examples of isotones? Okay, now C12 and, okay, one more thing. Instead of writing this, let me write C12 and N13. So here also you can see 6 neutrons are there. Okay, then oxygen 14. So these are all isotopes of carbon, nitrogen and oxygen, and they all have same number of neutrons, that is your 6 neutrons. Yes, they all have 6 neutrons because they are all isotones. Clear, everyone? And these have 6 protons, these have 7 protons, sorry, yes, 6 protons, 7 protons, and these have 8 protons, like this. Is it clear, everyone? Just give me tell me that if it is clear. Okay, let me give you some more examples. No space is there, so I have to remove the first one example and I have to give you the more examples. So you can see that like argon, potassium. Okay, so argon's atomic number is 18, atomic mass is 38. That means it has 18 protons and 20 neutrons. Potassium atomic number is 19 but atomic mass is 39. That means it has 19 protons and 20 neutrons. So you can see argon and potassium are isotones. Okay, argon and potassium are isotones. Even calcium is also isotone. See, calcium has 20 as atomic number and 40 as atomic mass. That means 20 protons and 20 neutrons. See, all have same number of neutrons. So your argon, potassium and calcium are again your isotones. Similarly, if we take the example of sulfur and chlorine. So we are taking the isotope of chlorine, that is your Cl37. Okay. So here the atomic mass is 37. So that means 17 protons and 20 neutrons. Here in sulfur 1636. That means 16 protons and 20 neutrons. So you can see here again both are having same number of neutrons. So all these 5 are your isotones. Ma'am, every element has isotopes. Not necessary, Avinash, not necessary that every atom will have isotope. Okay, it is not necessary. Clear? Is it clear? Tell me fast. Okay. But most of the atoms, they have isotopes, but not every atom. I hope it is clear to everyone and no doubt is there. Yes? Is it clear? So generally your like alkali metals, I don't think they have isotopes. Okay. So I hope everyone is liking this. So yes, okay, very. So miss every atom will not have isotope, but maximum atoms have isotope. Okay, so in alkali metals like cesium is having your isotope. Okay, so clear everyone? Is it clear? Just let me know. So everyone who are present in the class, I suppose is clear to everything. Everything is clear to them. Isotopes, isobars and isotones. Okay. Okay, Avinash. So thank you everyone for watching this class live. And tomorrow we have a special class at 5:15 p.m. So please do join that class. So thank you everyone. Bye. Good night and happy Republic Day in advance. Okay. Bye everyone.